September 27, 2022, the Andromeda Galaxy can be seen nearly overhead during early morning hours. Mars continues its eastward march through Taurus. Chart caption: Early autumn, Pegasus and Andromeda are in the southern sky after midnight. By Jeffrey L. Hunt. Chicago, Illinois, sunrise, 6:43 a.m. CDT, sunset, 6:39 p.m. CDT. Check local sources for sunrise and sunset times for your location. Overnight, Mars, Jupiter, and Saturn are strung across an arc from the east to the west-southwest. The planet parade is moving toward the evening sky. After midnight, find the planetary triplet. Look above Jupiter for the Great Square of Pegasus. The star Alpheratz, meaning the horse's navel, is the brightest in Andromeda. On old star maps, it was shared between Pegasus and Andromeda. Today, it is the brightest star in the latter constellation. Image caption: The Andromeda Galaxy, also known as M31 since it is the 31st object on Messier's list of diffuse sky objects, is the nearest large galaxy to our own Milky Way galaxy. Our galaxy is thought to look much like Andromeda. NASA photo. For sky watchers in dark locations, the nearest great galaxy, catalogued as Messier 31, M31 on the chart, is high in the sky, nearly overhead. It is barely visible to the unaided eye. Others need a binocular to see it. The island of stars is at least 2 million light-years away. Its distance was initially measured by Edwin Hubble, honored with the name of the Hubble Space Telescope. Hubble and his protégés worked to determine the distance of galaxies and the age of the universe. His initial estimate of Andromeda's distance was 900,000 light-years. He noted the rate that stars known as Cepheid variables cycled their brightness in the distant galaxy. Many galaxies are too far away for telescopes to see individual stars and the Cepheids. He settled a long-standing debate whether the Andromeda Nebula, as it was known, was a cloud within the Milky Way's known boundaries or it was an island of stars in the universe, another galaxy. Hubble used the Doppler effect of light to determine the velocities of galaxies. This occurs when the wavelengths of light are stretched because of the separation speed of other objects. He found that the more distant the galaxy, the faster it was receding. A similar effect occurs with an ambulance's siren. It is a higher pitch when it approaches and lower when it recedes. Today this effect is used by weather radar to look for tornadic activity and rotating storms and law enforcement traffic radar, among others. Hubble's distance and speed discoveries did not indicate that the Milky Way is at the center of it all. Rather, Einstein suggested that the universe is like a loaf of baking raisin bread. The raisins, galaxies, all experience the expansion of the bread and they measure all the other raisins moving away from them. Photo caption: The Great Galaxy in Andromeda, Messier 31, from the Galaxy Evolution Explorer, photo credit, NASA/JPL/California Institute of Technology. One of the unsettled values in galactic distance is known as the Hubble constant, also known as H0. Hubble's velocity-distance relationship is an important measurement because it helps us estimate the universe's age. When this data, distance and speed, is plotted on a graph, the line slopes to the upper right. The algebraic slope is H0. The reciprocal is the age of the universe. Hubble's initial measurement was 530 km per second per megaparsec. That's quite a mouthful. Essentially, for every million parsecs of distance, the speed of the distant galaxy's recession increases 530 km per second. A parsec is a unit of measure combining light years into larger units, like combining feet to make a yard or mile. 1 parsec is 3.26 light years. A megaparsec, of them is 3.26 million light years. To find the age of the universe, take the reciprocal of 530 and multiply by the number of kilometers in a megaparsec. The answer is in seconds. Remember those treacherous unit conversion problems in high school science classes. This is one of them. Convert megaparsecs to kilometers and second into years. So, Hubble's initial estimate of the universe's age was about 2 billion years. Throughout the last century, the Hubble camp refined the H0 value to 50, while others argued it was 100, placing the age of the universe between about 10 billion years to 20 billion years. Larger values predict a younger universe. Today's accepted value is about 75, placing the age slightly less than 15 billion years. The difference in values is the manner in which galaxies' distances are determined by using bright stars, sizes of galaxies, and sizes of nebulae within them, among many others. This story has many nuances and details that would cover many articles here. For a look at the history of the Hubble camp of thought through the late 20th century, read Dennis Overby's Lonely Hearts of the Cosmos. Be on the lookout for another value to be published from Webb Space Telescope observations. The headlines will herald a new age for the universe from the analysis of infrared light from distant galaxies. The new age will be from another measurement of the Hubble constant. Practically, the value will be averaged in with the other measured values. Regardless of this seemingly inane math and elusive value for H0, step outside overnight to see the bright planets and the nearest galactic system to our home Milky Way. Here is today's planet forecast. Morning sky. Chart caption, 2022, September 27th. Mars is high in the south before sunrise. An hour before sunrise, bright Mars is high in the southern sky, marching eastward in Taurus, closer to the Bull's Horns, tipped by Elnath and Zeta Tauri, than the head, outlined by Aldebaran and the Hyades cluster. Chart caption, 2022, September 27th. Through a binocular, Mars and Zeta Tauri appear in the same field of view. Through a binocular, Mars is in the same star field as the southern horn Zeta. Chart caption, 2022, September 27th. Jupiter is low in the west before daybreak. Jupiter is low in the west at this hour. In about 10 days, Jupiter is below the western horizon at this hour. Before then in 4 mornings, Jupiter sets as Venus rises, a planet-to-planet opposition. After that date, Jupiter sets before Venus rises. This morning the morning star rises only 34 minutes before the sun and it is low in the east during very bright twilight as daybreak approaches. Venus and Jupiter can be found through a binocular at opposite ends of the sky. Jupiter, NASA photo. For sky watchers with telescopes, look for Jupiter's great red spot on the center of the planet in the southern hemisphere at 5:40 am CDT. Because the planet is lower and twilight is brightening, look up to 50 minutes earlier, when the Jovian Giant's rapid rotation brings it into view. Mercury is quickly entering the sky after its recent inferior conjunction. Now rising 37 minutes before the sun, it puts on a short performance before sunrise beginning about October 8th. Evening sky. Chart caption, 2022, September 27th. The thin crescent moon is low in the west-southwest after sundown. About 45 minutes after sunset, the thin crescent moon is low in the west-southwest. Find a clear horizon to see the razor-thin moon, 5% illuminated. The Scorpion's claws, Zubin el-Janubi and Zubin al-Shamali, are above the lunar slice. Chart caption, 2022, September 27th. Jupiter and Saturn are in the eastern sky after sunset. As the sky darkens further and the moon sets, Jupiter and Saturn are easy to spot farther eastward. Saturn is less than 1/3 of the way up in the sky near the stars Deneb al-Jidi and Nashira in eastern Capricornus. Saturn is still retrograding, the illusion that the planet is moving westward compared to the stars. Chart caption, 2022, September 27th. Through a binocular, Saturn approaches Iota Capricorni, Iota Cap. It approaches the star Iota Capricorni, Iota Cap on the chart. The ringed wonder seems to revert to its eastward course in less than a month. Bright Jupiter is low in the east. One night after its opposition it is about midway through its retrograde in Pisces, near the border with Cetus. Saturn leads this planet parade westward. Mars rises before midnight and during the early morning hours, the 3 planets are strung across the sky and that magnificent galaxy is nearly overhead again.